33 and 34 are two problems that you're asked to factor in. The leading coefficient of these problems, the phrase the leading coefficient means the coefficient of the first term. Okay, what it is in this problem that lets you know how you do these problems is because it has a leading coefficient of 1. So 33 and 34 are both examples of problems that have leading coefficients of 1. And when that's the case, the way you know how to solve these problems is by looking at the C term, the third term, the constant sitting out there by itself, and asking yourself, what are the factors of the last term that add together to give you the middle term? I saw this online last night as I was watching some videos and trying to figure out how I could help you guys out some. Some people will list those out. They'll list the actual factors of 5 out, almost like an ordered paper, if you will. They'll say one of the factors of 5 is 5 and 1. Another factor, well, it turns out that's the only thing that you have a choice for in factors of 5 that have given you 6. So in this problem, you take this C sitting out there by itself because the leading coefficient is 1. You ask yourself, what are the factors of 5 that have given you 6? So it's x plus 1 times x plus 5. Next video, I'll put an equal 0 out here on the end, and then we'll have to understand that if it's equal to 0, we have to solve it on down and say x equals the opposite of each of these things. If that's not the case here, we simply have a leading coefficient of 1 and the factors of 63. So if I want to take the factors of 63 and write them out, I'm going to start at 1 and 63, 3 and 21. Eventually I'll get to 9 and 7. That's the factors that I'm looking for, because 9 times 7 is 63. And negative 9 plus a negative 7 is negative 16. So my factors of 63 that add together and give me 16 are x minus 9 and x minus 7. Once again, that's my final answer, because x times x is x squared, negative 7x and negative 7x. Those two terms add together to give me negative 16x. And if you remember just a second ago, that's what I said, what the factors are 9 times 7, the factors of 63, whose sum is negative 16. And then again, I stop right here because it's not equal to 0. If I look on ahead, just take a quick sneak ahead at numbers 37 through 39. I notice that those are all set up equal to 0. Or if they're not set up equal to 0, that's the first thing you have to do to them. You have a quiz star, there's one of your quiz stars that's solving for x, that's a linear equation. You just get your numbers on one side, variables on the other. Then there's another one that's solved for x by factoring. When you have to solve for x by factoring, after you get your factors, after you've got what you think the answers are, let's say, answers here, a plus b and c plus d, you set each of those factors, whatever they are, right? A plus b equals 0, c plus d equals 0, and then solve each of those equations for whatever variable you have in the problem, like x, or x squared you're solving for x, or y squared you're solving for y. In this case, I don't have a variable there, so maybe I need to solve this for a. So a would be equal to negative b, and c would be equal to negative d. It's called solving that equation. The reason I need to solve it is because it has equal 0 in it. 33 and 34 don't. So you simply got to stop when you have the problem factored out. Which also leads to the way that you can check these is by multiplying out and make sure it gives you what we started with.